Friends, welcome to my YouTube channel. Another interesting machine learning session. Today we are going to discuss about univariate analysis. It's part of feature engineering and it is also coming under exploratory data analysis. Let's start. So first let's have a quick introduction to feature engineering. It's very simple. Here we prepare the proper input data set and we will try to improve the performance of our machine learning model. The goal of feature engineering is simple. It converts data into features. That's all. This is the goal of feature engineering. Here we convert data into features. Fine. See, these steps, it's really important. When we talk about feature engineering, when we talk about the steps to prepare data to build your machine learning model, these are all the steps you need to follow. First of all, I have to tell you the quality of your inputs decide the quality of your output. That's the philosophy behind feature engineering. 80% of your time you are spending on feature engineering as a data scientist. So below are the steps involved. Variable identification, univariate analysis, bivariate analysis, missing values treatment, outlier treatment, variable transformation, and variable creation. The last video we discussed about variable identification. It's done. In this video, I am going to discuss about univariate analysis. Let's continue. See, let me give a quick introduction to EDA, Exploratory Data Analysis. It's really important. EDA is a set of statistical approaches to explore and understand data beyond hypothesis testing and experimentation. It is the statistical approach to explore and understand data. It is beyond hypothesis testing and experimentation. You need to understand. So EDA is simply, I can tell you, EDA, Exploratory Data Analysis, is a set of statistical methods to explore and understand data. In this EDA, mainly there are three methods we use. One is the univariate analysis, second one bivariate analysis, next is multivariate analysis. In this video, we are going to discuss about univariate analysis. Univariate analysis is the simplest form of statistical analysis. Uni, it's a Greek word. Uni means one, mono means one. So univariate analysis means your data has only one variable. Here you have only one variable. It doesn't deal with causes or relationships. In regression problems, we understand the relationship between data. Between the dependent variable and the input independent variable, or the input variable and the target variable. Right? So that's what we do in regression. But in univariate analysis, we won't do the analysis of relationship or the strength of relationship between variables. It's here we describe data. The univariate analysis is used to describe the data. It takes data, it summarizes the data and find its patterns. That's what we do in univariate analysis. For example, this is an example of a univariate data. It can be height or it can be weight. All these things are height of the students in a class or weight of the students in a class. So these things are examples for univariate analysis. This is an example. Height 164 centimeter, 115. This is a simple example for univariate analysis. See, the variables, or there are two types of variables. One is the continuous variable and another one is the categorical variables. See, variables are classified into continuous and categorical variable. This here I am discussing about continuous variables. What is a continuous variable? Example, height of the students in a class. It can be 160, it can be 155. It's an example for continuous variable height of the students. When you talk about the categorical variables, example, in a class, the number of students uh, you know who appeared in the exam and whether they the result whether it is pass or fail. So there are two categories. One is pass, the student can pass in the examination, or fail. It is an example for pass or fail. It is an example for categorical variable, pass or fail. Gender, male or female. So it's another example for categorical variable. Continuous variable means height, weight, these are all. So in the case of continuous variables, we need to understand the central tendency and the spread of data. This is, in statistics, we always use the central tendency and the spread of the variables. See, spread of the variables, it's also known as the measure of dispersion. See, when you learn physics, light rays, the dispersion you learn. Dispersion means how much it is scattered, how much it is spread across. The how much the data is spread across, that is the spread of the variable, that is the measure of dispersion. And the central tendency is given by the statistical quantities like mean, median, mode, min, and max. So these are all very important. We have separate video under the playlist statistics. You please watch those videos. You need to learn. Please learn these terms: mean, median, mode. Here I am not repeating again those quantities. So measure of dispersion, it's given by the quantities range, quartile, IQR. IQR stands for interquartile range. There is a separate video for interquartile range and quartile. You can watch those videos. Very important, terms in statistics. Variance. You can watch the videos in on the playlist. Statistics. Standard deviation. It measures the spread of the data, the dispersion of the data. All these terms, all these quantities define the spread of the data. Skewness and kurtosis, all these things are used to measure the dispersion. These terms are used to measure the central tendency. Visualization tools, visualization methods by histogram, box plot, violin plot. We have the separate video for box plot. That's for to find out the detection of outliers. We use a box plot. You can how we will detect outliers in feature engineering. There we use box plot, is also known as whisker plot. WHISKER, whisker, box plot, or whisker plot. See, all these things, the videos are available in the playlist statistics and feature engineering. In both the playlists, it's available. You please watch those videos. If you don't know these terms, mean, median, mode, range, quartile, IQR, variance, box plot, histogram, these are all important. Fine. So you understood what is a continuous variable. Then what is the univariate analysis for categorical variable? I already told you what is a categorical variable. For example, gender, or another, whether the student is passed the examination or not. So gender, male or female, these are all categorical variables. For categorical variables, we shall use frequency table. Very important. This is what you need to understand. To understand distribution of each category, we can also read as percentage of values under each category. It can be measured using two matrices we use, count and count percentage, against each category. Bar chart is used for visualization. Here we use bar chart. You have learned this bar chart even in the school. So this bar chart we use for visualization of the categorical variables. So that's about univariate analysis. So here we have the important thing is, here we have only one variable. Uni means one. That means your data has only one variable. That's the important point you need to understand in univariate analysis. So that's all about univariant analysis. There is bivariant analysis and multivariant analysis in exploratory data analysis, EDA. So that's all about univariant analysis. Thanks for watching. Please like, share and subscribe. Thanks a lot.